folks, this is question 6. First part, we have to construct the bisector of the angle XYZ. The angle XYZ is this angle down here. Before that is well, I'll just explain what to do. Is you have to use your compass. So you're going to put your compass on the point on the angle, and then you're going to draw an arc out here and up there. So something like that. And then you're going to take the pin of your compass down and you're going to put it where you made the point on the line on each one. So from the first one you're going to draw an arc out here into the middle like that, and from the other one you draw another arc out there. And that point out there, then that should be that should mark where you're going to draw in your bisector. So you draw a line through the point of the angle and that point that you made. So it's drawing an arc out onto the lines first, and then drawing 2 more arcs out there into the middle like that, and that's the perpendicular bisector, or sorry, not the perpendicular, but just the bisector of the angle. Then we have to construct the incenter. We already have a hint about what that's going to be. We're just going to do the same thing from another point, so you can take the point at X or the point at Z. I'll just take the one at Z there. So you're going to take the pin of your compass again, put it on that, and then draw an arc out there, and then draw another arc up there on that line, and then put the pin of your compass there and draw another arc out, and put the pin of your compass there, draw another arc out there, and then that's the line that it'll be through. And then you draw the line through that again. Now it's where those 2 lines, so it's there that the incenter is. And if you did it did the same thing with that up there as well, that it would go through the same point. So it's the bisectors of the angles, that it's where those meet. Right, part B, we have to use BC and DE to show that the scale factor is 3.5. Right, so BC is 4, and then it gets bigger by 3.5 obviously, but it gets bigger by something to give you 14, and that something has to be the 3.5. So if you 4 multiplied by 3.5, that gives you 14, so that's probably enough to show it. Or what you might the way they probably want you to do it is to do the 14 divided by 4, and that is equal to 3.5. So you're taking the corresponding sides on each shape. So the small triangle, that side is 4, so then the corresponding one on the other one is the 14. So if you do the 14 divided by 4, it tells you what the scale factor is. So that's all you have to do there. Then it says that AC is 6. So use the scale factor to find the distance from C to E. Well, there's one tricky bit in this at the end. If you were to imagine the small triangle there, so just the small triangle, so that bit there is 6 obviously, like they say. So the big triangle then, or the whole entire shape really, basically to get from 6 to whatever this is, we're going to multiply it by 3.5, because that's the scale factor. So 6 multiplied by 3.5, that gives you 21, but that gives you the whole of that side of the triangle. So 21 isn't the final answer. What we found is that there is 21, but this bit in here is 6, and they want us just to find out what C to E is. So they just want us to find out what this bit is here. Therefore you need to do the 21, take away the 6 at the end. So we're going to subtract 6 and you get 15. Then for the last part, this is the area of them now, so it's in units squared. So if I was to do 3.5 squared, that gives me 12.25. So that's the scale factor then for the area, because we have to square whatever it is. And then if you just do 11 multiplied by 12.25, that gives us 134.75. And that's units squared. That's it for question 6.